This is a short tutorial on how to use Science Express's ICP kit, Exploring Light. The materials in this kit are laid out by station. This is a station lab where students will have to rotate from station to station. There's an inventory list of what all is included, separated by station. You may want to have sticky notes or some kind of paper supplied by yourself for one of the stations. It's also important to note that the spectrum tube carousel will need to be requested from Science Express separately from this lab. That would be this guy right here. So Science Express does offer this, but in addition to requesting this kit, you should also request this to go along with it. Otherwise, Station 3 is not super exciting. This lab is set into stations. Each station has its own set of instructions along with questions you might like to use. Otherwise, feel free to use your own. We also have several charts to include on some stations that will help out your students, but also, again, feel free to add in additional materials as you use this based on how you run your class. For instance, you might want to have your students know the visible spectrum's kind of general range, say from 400 nanometers to 700 nanometers. That might be kind of hard to deduce from a chart like this. There's also a general layout of what is included in all of these stations, so you can use that to kind of unpack and also pack back up to help yourself out. Laser pointers are used a lot in this lab, so it's a great idea to have extra batteries on hand in case you need to change these out. These laser pointers tend to chew through batteries, especially if you have several classes through the day using these. Something else to note, some of these laser pointers have their contacts get kind of misaligned, so if your beam isn't showing through correctly, you might want to just give it a couple taps to make sure that your batteries are sitting in the right place. So if your beam's coming through a little weak, it might just be how everything's making contact. Station 1 looks at comparing the energy of light from two different bulbs as it comes in from a certain distance and angle. We do this by looking at these two bulbs, this LED bulb and this blacklight bulb, and compare how they can affect these radiometers here. I recommend having a block of some kind to rest these lamps on, so that way they don't roll around. And we can watch to see if the light bulb has an effect on the radiometer's movements. As light is absorbed by the different colored veins, either the dark or the light ones, we might see some movement, but if there's not enough energy coming from the light, we don't get enough heat transfer, so we don't have enough movement on the inside of these bulbs. Higher energy lights, like the UV and high violet light coming out of this blacklight bulb, tends to have a stronger effect. Higher energy light can convert into more heat, which can move more air on the insides of these radiometers. A thermometer is also provided if you would like to have your students see the difference in temperatures as the blacklight bulb gets a lot hotter, even though the LED bulb is going to be a lot brighter. We also have prism glasses that will show how the light splits up into its different wavelengths. So your students can see that white light is not just a single color of light, but a collection of many colors. Station 2 is all about how light can be absorbed, transmitted, or reflected, and how the color of objects relates to that. To show that, we've got a laser pointer, we've got a clear prism, so we can show how light is reflected and transmitted. We can talk about the color of the prism itself. We've also got some sunglasses and a simple LED flashlight. We can talk about, again, the color of objects and how light transmits through them. We've also got a swatch book of different gel colors that are used in drama theater and photography to change the color of light. We have some larger graphs of how light is absorbed or transmitted up here. They're also present in the swatch book, but these are blown up so a little bit easier to see. Station 3 is all about the light that's released as electrons get excited and then de-excite. Right? This heavily relies on the spectrum tube carousel that you can request from Science Express. So please, again, make sure you request that separately or else the station kind of falls apart. So the spectrum tube carousel is right here. It's got a power supply that plugs into the back, and it also has a power switch on the back here. If you need to change out the order of the lamps for any reason, just make sure you don't touch the glass of this, but you can lift up on this, and there's one slot on the top here that you can pull these out through. Just make sure they're correctly seated when you put them back in. These are numbered for a Science Express lab, but if you decide to renumber them to fit this lab or another set of instructions that you make, just make sure that you return the labels to what they were before you send the kit back. Turn this around and hit the power switch. This will display one color at a time, and you can rotate through to get different lamps if you'd like. The spectrum glasses will also allow students to separate out the different colors of light for each lamp, which can be used to figure out which element is giving off this spectrum of colors of light. The spectrum tube carousel equipment that you can get from Science Express also typically comes with these smaller diffraction gratings that act basically like the prism glasses if you'd like to use those, as well as spectroscopes, which can give you kind of a better reading on the wavelength that goes along with that specific color of light as it splits out. Station 4 shows us fluorescence and phosphorescence along the same lines of light emitted from electrons being excited and then de-exciting, but we lose some energy in the process. So the color we get out is a different color of light than we put in. We have a set of minerals that can be tested with a black light to show this, as well as this phosphor material, and these liquid chalk markers, which you can use to see which colors are actually truly fluorescent based on the color of light you get back out. Station 5 is all about fluorescence, specifically the energy of light and how it may or may not be able to cause fluorescence. If the energy of the light is too low, then no fluorescence happens, but if your light's energy is high enough, we can get a lower energy light coming back out. This also looks at which materials can fluoresce and which don't. Station 6 is all about phosphorescence. So similar idea to the fluorescence that's seen in stations 4 and 5, but looking at the light being released on a longer time scale. Just like with fluorescence, the energy of the light that's put in can determine whether phosphorescence actually happens or not. And different materials can phosphoresce while others may not.